Here we go. We have a question. Stock buy and sell. Multiple transactions allowed. So the cost of stock on each day is given in an array. Each day you may decide to either buy or sell the stock at the current price. And you can even buy and sell the stock on the same day itself. And we need to find the maximum profit that you can get. Note here is a stock can only be sold if it has been bought before, means previously, and multiple stocks cannot be held on any given day. So we have this example. If we buy stock at this index and will sell at this index, so we got 210 profit. And if we buy at this index and will sell at this index, then we got 655. So the maximum profit that we can get is this value. So we need to find the maximum profit that we can get. So let's try to build the approach. So we have this example, and in this example we need to check. We will buy the stock at the minimum value. We will buy the stock at the minimum value. First, we will check at this position. Is the current position, this current position is greater than next value, means the next value have smaller value, means we will not buy at the current day, we will decide it later if the next value is greater. So what I mean is, so we have array of I plus 1. If array of I plus 1 is less than or equal to array of I, so we will buy the stock tomorrow or later, and we will decide. So for example, we have this array 360, then 120, then 100, then 355, 625. So we are at this position. Is the next value less? Yes, the next value is less. Is the next value less? Yes, the next value is less. So we will not buy at this position, we will not buy at this position. We will decide it tomorrow. So we have a while loop, and if array of I is greater and array of I plus 1 is less, so we will buy the stock tomorrow. And as we are accessing I plus 1, so I plus 1 should be less than n. If this is the case, we will increment. So initially our I is at this position. Is next value smaller? Yes. Is next value smaller? Yes. Is next value smaller? No. So I is at this position. This is the smaller value. We are at a decline. We are at a bear market. So we will buy the stock at this position. So let's say buy at ith position. So we bought the stock at this position. We need to check, is the next value greater? So we will sell it tomorrow. Is the next value greater? We will sell it tomorrow. So we need to check, is array of I plus 1 greater? So we will sell it tomorrow. As we are accessing I plus 1, so I plus 1 should be less than n, and we will increment. So we will buy the stock at this position because the next value is not smaller. So we buy at this. Is the next value greater? Yes. Is the next value greater? Yes. Is the next value greater? Yes. Is the next value greater? No. So we sell at this position. So what we got is, we sell the value at ith position. Then we will increment our answer, sell minus buy. So we are at this position. So we will save the answer, and we will buy this stock and sell the stock. Next, again, outside this we also have a while loop, which is I less than n, this only. So we will check, is the next value smaller? Yes. First of all, we will take this. First of all, we will take this. Next, we will check, is the next value smaller? Yes, the next value is smaller. Is the next value smaller? No. So we buy at this position. Is the next value greater? Yes. Is the next value greater? Yes. So we sell at this position. We sell at this position. Then we will just go to the next index, because now the next value is not accessible. So if I go I plus plus, then there is no harm in this. So let's again walk through of this approach. First, is the next value smaller? No. So we buy at this position. Then is the next value greater? Yes. Next value is greater. So go ahead. Next value greater. Go ahead. So next value is not greater. So we will buy this stock at this position and sell at this position. Then we are at this position. Is the next value smaller? No. We have to buy at this position. Is the next value greater? Next value greater. So we sell at this position and buy at this position. So this is one another range. Now if we go ahead, we are out of bound. So the maximum profit that we can get is the difference of this and difference of this. So that's how this approach will work. So let's code this. So let's look at the coding part. So we have this function, and inside this we have maximum profit. So this is the variable that we want to return. So then we have a while loop. Inside this, if upcoming tomorrow we got smaller value, then we will buy tomorrow. Then we will buy the stock on tomorrow. So if I plus 1th value is smaller, so then we will increment. And this is the ith index. On the current day we will buy the stock. Then we need to find the sell point. We want to sell at maximum possible value. If upcoming tomorrow we got greater value, then we will sell the stock tomorrow. So if I plus 1th value is greater, means we want maximum profit, so we will sell tomorrow. So we have sell at ith index, and we will uh, we will add the price into our maximum profit. After that we will just increment to the next index, and at the end we just need to return our maximum profit. So let's give it a try. And in between, let's talk about time and space complexity. In the while loop we have we have a nested while loop, but we have same variable. So the time complexity is order of n itself, and space complexity is constant. And we have successfully solved this question. The code is given in the description box. If you guys have any doubt, feel free to ask in the comment section. And we also meet the expected time and space complexity. Thank you all for watching.